Okay, thank you. All right, again, thank you very much for letting me come here, and I've been very giddy all week because I've just had so much fun, so I appreciate the invitation. I want to talk today about a topic that I haven't ever seen really addressed before, but seems to be kind of a natural one, which is if we think about information and the amount of information that a proposition or a sentence conveys, how to evaluate self-referential sentences, and in particular, how then, if we had a handle on how to evaluate the semantic information of a self-referential sentence, how to evaluate something like the liar or the truth teller or other sort of paradoxical things. So we always approach these things sort of alethically, I think, right? There's a preference for talking about these things about whether or not they're true or false, but it seems, right, like a distinct question to ask about what their content is or what the information that they convey is. So I am going to sort of, this comes, right, with a bit of a mea culpa. I wrote something that came out about 1.5 years or 2 years ago about semantic information, and I realized that I was totally wrong about something. I think it was interestingly wrong. I don't think it was necessarily an entirely rookie mistake, but it does indicate that I think that there are reasons to really start thinking about how information and self-reference intersect. So what do I mean by, also let me give the standard qualification. At any time, I welcome people interrupting me or shouting at me or anything, so please feel free to do that. So what is semantic information? I think the most natural way of sort of approaching this is by thinking of the amount of information that something conveys as corresponding to the number of possibilities that a statement precludes. And I've always found that a really nice indication or illustration of this is the game of Guess Who, right? So has somebody played this game? Guess Who, right? Your opponent has a bunch of faces, you have a bunch of faces there. You've selected one face, you know your opponent has selected one face, and by sort of a process of elimination, you ask, does your character have white hair? And they say, no, and now I can knock down the little white-haired faces. And by asking questions, eventually, right, you're supposed to be able to eliminate the possibilities, and that's how you win the game. And so that seems to me that what's going on is essentially sort of conveying information back and forth. It's the whole play of the game. And this sort of very initial sort of account, this sort of naive account, does sort of tell us about how we can compare the amount of information. So if I'm playing Guess Who with you, and I find out that your face wears a beard, right? Since only, 4 of the characters wear a beard, right? That has eliminated 20 possibilities. And so that's very, very highly informative. If I ask you, does your character have brown eyes? And you say, yes, I can eliminate 7 possibilities because most of the characters have brown eyes. So we see some kind of ordering in a sense about how to make sense of something's being more informative than other sentences. So I think just in a very sort of, I think this captures, at least for me, what I tend to think of as informativeness or semantic information. And the sort of gold standard historically for this has been the theory of Bar, Hillel, and Carnap. You find this in an MIT tech report, and then it is also published in some other venue in 1952. And they take, right, this sort of notion of precluding possibilities very seriously from a formal perspective, and they take this space of possibilities to be logical space. And a hallmark of this, right, is this so-called inverse relationship principle, that the amount of information conveyed by a statement is inversely proportional to some measure of its possibility, right? So trying to make this a little more, okay, I'm gonna set aside the matter of whether this is supposed to be considered possibility or probability. But, right, to see an example, Barlow and Carnap consider unary predicates, a finite language with unary predicates and some constants, and so, wow.
I think
You're stepping a bit, lower than me.
I will now shuffle over to this side. Is it still purple? No, it's not purple any longer. Okay.
a little purple.
A little purple. That's not bad. It's not deep purple, at least.
Yeah.
So if we have a language, right, in which we have just two unary predicates and two constants, then the sort of picture of logical space that Barlow and Carnap presuppose is going to look like this, right? There's going to be a space in which none of these things are satisfied, right? There's going to be a space in which all of them are satisfied, and then every sort of permutation of these, right? Or, you know, it's the power set of this, right? So you can look at this as sort of valuation space, right? And look at each of these partitions as the sort of models that verify the literals that are in there, or atoms that are in there. So again, this in many cases seems to line up and conform with, right, our sort of naive intuitions, right? So if I tell you in this space that, look, I mean, PA and RA is true, then what I've done is I've stricken from this list all of those possibilities in which either PA is false or RA is false. Right, remaining, all I can retain then are those states in which, right, both of those atoms are satisfied. And this seems to line up, right? That's a pretty highly informative thing. I mean, more informative still would have been PA and RA and PB and RB, right, which would have eliminated 15/16 of the possibilities. And likewise, if I sort of assert at this junction, right, again, this seems to sort of line up. If I said PA or RA, then I've only eliminated those possibilities that failed to satisfy either or both PA and RA, right? And therefore, this precludes only a quarter of the possibilities. And therefore, strictly speaking, it seems, and Barlow and Carnap's model maintains, that this is going to be less informative. Okay, so I find that pretty compelling. And in fact, on this level, for formulas of this form, I think most people do tend to find this very compelling. Where it starts feeling a little bit wonky is at, of course, the antipodes, right? Just like everything else. When, for example, we think of a tautology, PA or not PA, am I able to strike any possibilities from valuation space by asserting an instance of excluded middle? On Barlow and Carnap's account, no, right? I haven't. It's entirely uninformative. It is not. I can't use a formula of this form, right, and conscript it in order to get a more fine-grained account of logical space. I can't use it to eliminate possibilities, to guide my life, to investigate anything. It's just null in a sense. And that holds, right, for all sort of theorems of classical logic, at least in the unary fragment. And this, notably, right, was dubbed by Hintica, who took, right, a serious interest in the sort of intersection of information and logic. We call this the enduring scandal of deduction, right? As a play on the scandal of induction. And so this, it seems to sort of conflict with our natural disposition that when we are teaching somebody logic, right, we've actually taught them something. But on this account, it doesn't work. And on the other side of the spectrum, we have another sort of possibly counterintuitive thing, which is that a contradiction or anything that's logically unsatisfiable, right, strikes everything from logical space. And therefore it is maximally or infinitely informative in some sense, right? Or just maximally informative. it strikes 16 of 16 possibilities, right? And so this, on the model, I think makes a lot of sense. But there is a sense in which this might be found to be counterintuitive. So there's a quote from Barlow and Carnap where they identify this. They write that it might seem strange that a self-contradictory sentence, hence one which no receiver would accept, is regarded as carrying with it the most inclusive information. Right? So they acknowledge that it might seem strange that something that nobody would ever agree with would be informative in any sense, much less highly informative. Right? There's sort of a policy for this is that it should be emphasized that semantic information is here not meant as implying truth. A false sentence, which happens to say much, is thereby highly informative in our sense. A self-contradictory sentence asserts too much, right? And there's a beautiful line right there. It is too informative to be true. I tend to find that to be satisfactory. In the same way that I tend to accept that, all right, maybe contradictions imply their own negations, and maybe there are irrelevant, right, inferences from contradictions in which there's no relevance between the antecedent and the consequent. But you can also see why this might be considered strange. And it indeed, it conflicts with some of the more recent theories of information, well, a number of theories of information that have been going on for the last 40 or 50 years. So one thing that this classical theory of Bar, Hillel, and Carnap allows for is this so-called contingency constraint. I'm calling it contingency constraint. That a true statement, and by the way, I am absolutely guilty of conflating statements and sentences and propositions. I'm perfectly fine with that. I don't think anything hangs on it. And so I acknowledge that that's probably a little sloppy, but for my purposes, I feel pretty comfortable with it. But they endorse this contingency constraint, or at least it's implicit in their work, that a true sentence conveys no information if and only if it is a necessary truth, right? So, I mean, if you go back and look at logical space, right? What are those propositions that do not preclude any possibilities? They're precisely our logical truths, right? So the class of uninformative and true sentences is identical to, right, logical theorems. And also the sort of opponent theories, right, which I'm going to call vertical modal theories, right, also endorse this. So this is something that generally everybody seems to accept, that the only class of uninformative sentences, if there is one, is going to be those that they're true, right? True and uninformative sentences are going to be necessary truths. Okay, so number, right, of theories have been floating around, famously sort of reflecting this thesis of Dvoretsky, that it is a necessary condition for something to be informative, that it be true, right? So, I mean, he famously has this sort of really wonderful quip about false information is not information any more than a decoy duck is a duck, right? So, this I'm going to capture by this verticality thesis, that a sentence conveys information only if it is true. Now, this is notably, right, not found with the Bar-Hillel-Carnap classical theory, right? Because contradictions convey information, falsehoods convey information, so long as they are capable of making a distinction in valuation space, then they convey information. But the sort of contra-classical theories, right, reject that. So I'm going to say this. I'm going to say that they accept the contingency constraint. I'm going to say they accept this existence constraint as well. Okay. Also, right, it strikes me that self-reference, right, in itself is not something that sort of should prevent us from thinking about the information content of something. right? So you have a sentence like this, 6 words appear in sentence 1, and that's sentence 1. That strikes me as informative, that it's telling me something about the world, right? It's true, I can give you a reason for its truth, I can consider cases in which it would have been false and so forth. So this is the kind of thing that I think sort of demonstrates that self-referential statements are sort of within bounds if we're thinking about theories of content or semantic content or information. Yeah. So it asserts that a contingent property applies to it, and that's sort of one of the hallmark cases in which we think things are informative. So in order to get through, I'm gonna pop through that. I want to talk about this earlier paper that I've written. It strikes, so I had written a paper that sort of argued that, look, if you endorse a vertical modal theory of semantic information, I can produce self-referential statements that are unevaluatable in your theory, but are perfectly coherent modulo the Bar-Hill and Carnap theory, right? Which seemed to me to be a sort of reasonable move. If I can produce things that are paradoxical in one theory, but my theory can handle perfectly well, that strikes me as a relatively fair case against it. And my sort of general statement was that these vertical modal theories have been sort of thrown about in order to get away from this so-called Bar-Hill-Carnap paradox that contradictions are maximally informative. And so what I sort of wanted to suggest in this paper was, look, you have found a sort of polite paradox, something like Banach-Tarski or Skolem or something like this, where it's just sort of counterintuitive. And so that the Bar-Hill-Carnap paradox seems to fit into that mode. And, oh, evacuating? All right. So my basic position in this paper had been against the sort of upstart vertical modal theories, and which are motivated by the fact that there's this mild paradox in the Bar-Hill-Carnap theory. And my basic claim was, look, you've exchanged a sort of mild paradox for a real inconsistent paradox, like the show-stopping kind, like Russell's paradox. And that the Bar-Hill-Carnap self is perfectly capable of handling that, and therefore, maybe we should accept that. So as a first pass, and maybe an illustration of how some of the subtleties of looking at the information of self-referential stuff come into play, is something like this. As a first attempt, if you wanted to try and be a smart aleck and say, I'm going to prove your information theory to be inconsistent, you would probably try something like this. Well, this sentence conveys no information, right? But vertical modal theories are perfectly fine with this, right? So suppose a sentence is false. Then by the verticality thesis that they endorse, it conveys no information and it's true. So that part, from its falsehood, you get its truth. But, right, if you do assume the sentence is true, then by this contingency constraint, it must be necessarily so. And that isn't really problematic, because this, by using a demonstrative, right, you might think that this sentence conveys no information, refers to itself via sort of rigid designation or something, and that if it in fact has these essential properties, that it is in fact necessarily the case, right? So the vertical modal people have a perfectly good way of handling something like this. They say, okay, it's true, and it's necessarily true, and it's uninformative. That sort of resolves that. But if we think about something like this, in which there is not necessarily self-reference, only apparent self-reference by means of a definite description. So this is, look, this looks to be the end, almost identical. to this. And in fact, I do, right, let's talk about this first, and then I want to make a sort of historical point. The boldface sentence on the slide conveys no information. So how would the vertical modal person try and analyze this? Well, they'd say, well, look, if it's false, then by the vertical theory or verticality thesis, the sentence conveys no information and it's true. So we know it can't be false because that would be contradictory. So if it's true, then since the vertical modal folks endorse this contingency constraint, it must be necessarily so. But it can only be contingently true. Why can it only be contingently true? You can suppress things about that slide right now, but this seems to sort of only indirectly refer to itself. I could have written a number of different boldface sentences on that slide. I could have written, you know, there was an 8.1 earthquake in Mexico last night on there. That would have been informative. So this is, if this is in fact true, it could only be contingently true. So the distinction between this and this is really in the mode in which they self-refer, if you can say that referring to yourself through a definite description is in fact a reference. And this is a problem for vertical modal theories. But if you're part of Hillel and Carnap, you're fine. Okay, it's false and it's informative. It divides up the logical space into those worlds in which this sentence conveyed no information, those worlds in which I had written an uninformative sentence on there, and from those worlds in which I chose to write an informative sentence on there. And so the classical analysis is totally coherent on that account. The historical point that I want to make, though, is that I've never actually seen anybody think about the mode of self-reference in these cases. And if you look at the expositions of these things, like when Tarski introduces it, Tarski's sort of version of the liar refers to itself indirectly. And therefore, if it is paradoxical, it's only sort of contingently so, right? Because you imagine Tarski could have written a different line in that paper, right? Whereas, other presentations of the liar, like ones where they identify itself, seem to be sort of necessarily paradoxical. And so I've never really seen that distinction made between contingently paradoxical and necessarily paradoxical, but I do think it's kind of interesting to reflect on. However, you can also, if you have any kind of issues about the self-reference, because it strikes me that somebody could say, well, look, it is necessarily uninformative, because this slide presupposes that it has that particular sentence on it. Like if you have a theory of identity of slides across time or something, maybe you'd say that's indeed rigidly designates itself. And you can just take that. We've had this sort of existence criterion where there is some informative sentence, and then you can just take this. This sentence conveys no information, and C, where C is just some random informative sentence. And you get the same sort of paradoxical thing. If it's false, either it's informative or C is false, but both of those are problematic, If this 5 is false, the verticality thesis entails that it's not informative, so its informativeness would mean it's not informative. C was selected by hypothesis to be true, so that can't be the case either. So if it's false, then you get a contradiction. If it's true, then because C is true, the compound conveys information, and that contradicts the first conjunct, presuming that these aren't contradictory with one another. Oh, because it's true, yeah. So on the vertical modal theories, this is problematic as well. But the classical analysis can just say it's false and uninformative. False and informative, So something like that, again, like Carnap folks can handle it, Jaretsky and Floridi folks cannot. So, me being cheeky, I thought it was really clever to say, well, look, you have got these inconsistent sentences that mine can handle perfectly well, and that wasn't all that bright, so this is my sort of maniacal. This is like my fault. Is that, so there are sentences that the classical theory can't handle, but the vertical theory people, the vertical modal people can handle just perfectly, Like this sentence is false, it conveys information. So you know how this is done, If it's true, it also says that it's false, so it's contradiction. If it's false, then it necessarily conveys information that satisfies both conjuncts, because on the Barlow-Carnap theory, all falsehoods convey information. That satisfies both conjuncts, and that means that 6 is true. So, Barlow-Carnap can't handle that. Critical modal people say, well, would say, just, okay, well, 6 is false and conveys no information. So I compared this last night to having two sort of incomparable extensions of piano arithmetic, right? Each of which can prove the other one's right Gödel sentence, right? The fact that I can prove your Gödel sentence and you can't doesn't insulate me in any way from having a Gödel sentence of my own. So that is an amendment to earlier work that I feel compelled to say. So the original argument is much less interesting. Oh yeah, that's my little, this is the lesson that I drew, right? So sufficiently expressive languages, including a truth predicate, are bad news, right? Who knew, right? So unfortunately, the argument in the paper I don't think was any good at this point. But it still, I think, suggests that there's something kind of interesting about thinking about information in this context, because you have these sort of modal considerations, and you've got, right, it brings out subtleties that I don't think are necessarily prevalent in just a sort of vertical account, where we think about the truth value of a liar sentence. So, solutions to paradox like the liar, they tend to be concerned about matters of lethic matters. But as I said, right, I haven't really found a great deal of work, any work on thinking about what paradoxical sentences convey. And so I want to start trying to kind of propose how I think that might be done. And I realized on the way over here, something that is sort of unfortunate about the approach that I still need to hash out, but I'm going to tell you about it when I get there. But let's start by just thinking about sort of how the natural evaluation of like a liar sentence goes. It seems that when I explain the liar to somebody, or when the liar was first explained to me, that its evaluation is sort of iterative, right? I was told that if the liar sentence is true, do a little work, then it's false. But, right, now next iteration, we'll consider it to be false. Well, then it's true. And then you can apply this again. That, look, but if it's true, then it's false, and so forth. So it seems that you can make a case that this is iterative in a sense. And certainly, I think on the sort of Tarski account, right, it is iterative. Like, you can't just stop. It keeps on going up all the way to the hierarchy with truth predicates, right? So it seems that if we think about something like this, it's sort of a procedure that calls itself, that that might provide a way of thinking about the informational content of things like this. So where I'm going now is a little bit sketchier and hazier, and I don't have a theory. I have sketches of what a theory could look like, or what a procedure for implementing a theory might look like. But let's think about liar sentences as sort of recursive procedures. Then maybe we can think about how to get a handle on just the informational content of recursive procedures in general, right? And it's not clear in a language as impoverished as the one that Barlow and Carnap use, how to represent in predicate logic, for example, without being able to encode things, that something is recursive or calls itself. But this sort of thing strikes me as a fairly reasonable first attempt to codify that. That this sentence, P0A, right, is identified with P0A and some other stuff. So if you were to evaluate something like this, it seems like it's sort of, again, calling itself. Well, what is the evaluation of P0A? Well, okay, first we have to evaluate C1 or CI. Yeah. Oh.
Just clarification
Yeah.
question. So what is the sort of standard, just, if you had, I mean, letting A be identical to that sort of sentence? What is that not doing that what you have up there is doing? Like because you still have the sort of, in order to evaluate it, you have to look at what A denotes and so on. So rather than P0A equals, I mean, I guess all
right, you could keep this as a propositional language, I guess. I mean, I'm just trying to sort of conform to the Bar-Hillel-Carnap specification of these are always unary, sentences are treated as sort of, or atoms are unary predicates applied to a constant.
Yeah, in which case, why don't you just have the constant A, in effect denoting that sentence or the result of whatever? Why do you need what you have up there, which I'm not entirely sure how to read, but. Like A just is P0A dot whatever.
We don't have, I think that's probably reasonable to pull as well. It seems like you're gonna have a code or something, right?
Or some fundamental relation that gives
Yeah.
you denotation.
So it doesn't strike me that we could introduce like a unary call predicate or something that, right? CA, right, somehow with some funky stuff in here, right, calls, right, or I guess calls A names some formula. It seems like there are probably ways to do it, but as I said, this is still very sketchy. I'm not sure that I'm entirely content with it. But I did want to keep the resources very limited because I want to have this sort of harmonious with the Bar-Hillel-Carnap thing.
Okay, sorry.
Yeah, no, but look, I'm going to mention like liars as things, and I'm going to keep the same format where the relationship is just that it is identified with its negation in some sense. And that's in some sense unsatisfactory to me, but I think it's general enough that it could sort of be that you could incorporate like a call predicate in there. Yeah.
Sorry, I really am sorry, but
no,
I'm just trying to get in on what you're after, because like there are two things. There's this work by old work by Albert Visser where he talks about sort of taking a propositional letter and you can substitute into itself. And it's sort of the kind of loopiness that it looks like you're after. That's one thing, but I thought when you have a sort of more first order or predicate and a name in the language, then you could just have the name denoting the sentence in the usual way. I mean, you need names of the sentences in your language, but
we're in fact working in a propositional language. If you look at the slides with Carnap, right? It's right. There's like the decidability of the sentential or the unary fragment of classical logic without quantifiers, right? Because you just reduce it down to propositional logic.
I got that.
So this is, essentially you can just look at P0 as just P0 as not a predicate but a propositional constant or something.
Right, but why then do you have? Why do we even have names in there? If they're not naming things, then why bother? Why not just have propositional variables?
Just historical.
Okay.
I'm just trying to conform as closely to that.
Got it.
I do like the Bar-Hillel-Carnap paradox, or I like the theory. I'm really sympathetic to it. I think that maybe contradictions are sort of infinitely informative. Maybe they're not. I'm not really all that unhappy about it. I think that the general framework seems pretty spot on. I want to be able to represent this in there. If it requires a little bit more cruft eventually, that's cool. I'm not against that, but I think that what I'm going to say is general enough that you could represent things in this way. what I know doesn't work is representing these things as sort of material conditionals. Like that, look, if P0 then, or if C1, then P0 or something like this. Like those don't work because they just sort of devolve into conjunctions, which are relatively unhappy. The identity here is just so that now I know that P0 is true, now I call it again, which is why I'm sort of motivated to think of like a calling predicate or something like this. Okay, are you?
All right, sorry.
Yeah, no, thank you. No, that is extraordinary. If there's a pre-existing way to do it, that is awesome. So thank you. Okay, so let's try and emulate a recursive procedure in this way. I'm going to use a marker. I saw everybody doing, when I saw Guillermo yesterday writing over his slides, or maybe Monday, I got kind of inspired and I thought maybe I can do something more with that. So let's look at something like this that emulates some kind of propositional constant. Again, you can just drop the A's if you want. That's perfectly fine. And is identified, right, with a conjunction of itself and then the next sort of iteration up, right? So PI is identified with the conjunction of itself and one step up. So how might we try and evaluate this in terms of what it precludes in logical space? So here's logical space. It is a square. Now, what might this look like? Well, if we have P0, let's let this axis be P0. And then let's let above it all the things that sort of verify P0, and let's let below it all the things that, right, don't satisfy it. Then if I assume P0, then if it's true, what do I do? Well, I rule out half of logical space, right? That's just everything receives a prior probability of 1/2, right? Okay, but now I iteratively repeat this, right? So I have P0 is true, and so now I know that P0 and P1 are true. Well, let's let this axis be the P1 axis. And let's say these are the things that are not, and these are the things that are. What have I done now? I have now ruled out by the second sort of iteration a big chunk of logical space as well. Oh no. Okay. This next slide might not work well, but yeah, it didn't work. Okay, let's say the next axis though. I need to think. Let's say this next, so it's the next iteration, right? We know P1 is true, and so we know that P1 and P2 are true because it sort of iteratively called itself. And so let's let this be the P2 axis. Everything on here is a P2, everything here is not. Well, now I've ruled out that, and I can carry this out. So slowly, as it calls itself, it continues to carve out a smaller and smaller and smaller portion of logical space. And so what then would sort of, how would we treat this information of this sort of emulation of recursive procedure? Oh, wait, look at this. This only works as far as it goes. But now you can see. How does this sort of emulate it? Well, what would the information content? Well, it would take a limit, right? It would eventually sort of rule out almost all possibilities, right? All possibilities, but it would do so sort of iteratively, right? And oh, there we go again. Therefore, right, you can see this is maximally informative, but not, right, maximally informative in the same way that a contradiction is, right? Rather, because there is sort of a model for it. There is a state in logical space. It's just almost all, right? It's cofinitely many states in logical space fail to verify it. So it's maximally informative, but in a very different sense than just sort of saying, you know, P and not P. All right, so let's try this again. Let's see if I can remember where the lines are drawn. Okay, got logical space. So let's let a recursive procedure be a disjunction now. So P0 is P0 or P1, P1 is P1 or P2, and so forth. So how might we try and evaluate this on a sort of quasi-bar Hillel Carnapian picture? Well, again, we've got logical space. Yeah. So let's let this be the axis for P0. Well, then if P0 is true, then this is what's not P0, this is, then we can rule this out. So we've eliminated half the possibilities. Now what do we do? Because it's disjunctive, however. Right now, suppose we have P0 or P1, and let this be the P1 axis. Right, so that everything here is P1, everything here is not. Will that get me into trouble? I mean, I'm looking at the same problem. I'm hoping that I can avoid it. But then what does this do? Well, where the conjunctive things sort of continue to rule out possible states, right, what this does is sort of recover them for us. What this does is say, well, look, okay, P0, we know this to be true, but maybe P1 is as well. And so instead of blocking things, right, we start recovering them. I'm in the same problem. Let's say that these are, those are the good ones, right? Then here, what this has told us is that like the only things that are ruled out are the things that fail to verify both P0 and P1. And then let's look at the next iteration, P1 or P2. Let's do the P2 axis. Everything over here is a P2, everything here is not. And so what have I done? Again, I've freed up space.
No, it's the other way, right? Where the things
there, it's ruled out, it's freed up that space where P2 might be true as well, right? So what we can iterate this, right? And what do we eventually get? We get, right, sort of the opposite of this. We have this as being sort of minimally informative because it frees up so much stuff that that one state that fails to verify any of these sort of P statements, that's outnumbered, right? Cofinitely many things satisfy it. Only one thing fails to satisfy it.
This is a small note about the diagram.
Yeah.
By seeing your diagram, I remember these diagrams, this method that is used when designing circuits that is called Carnot maps.
Yeah.
Yeah.
Yeah, because you're a computer scientist and you get that in your textbook.
What?
You get that in your textbooks as a computer scientist.
Yeah. So it's, I guess this is just what you're doing is just like taking that method and extend it to the infinite, because it's the regular procedure that engineers use to design circuits.
All right, I'm gonna go look at that. I mean, if I don't get so severely beaten down after I finish, and it's still worth pursuing, I'm totally going there, thank you. Yeah, I mean, I thought about, I mean, you could sort of think of this as sort of like in n space, right? I mean, like, this is, ultimately logical space is sort of like a infinite Hilbert space or something, right? But yeah, I will go and look and see if that produces anything good. Okay, I think that these things seem to me kind of natural, right? They seem to sort of be right. Now, what happens if we try and apply this to something like the liar? So, yeah, again, I described that I think there's a sort of iterative element to evaluating the liar, certainly if you do a Tatarsky style thing. And now JC's gonna be really mad at how I represent it. That's fine. So one way to look at this, right, if we look at this in sort of classical logic, then we do get maximal informativeness, right? How do we do this, right? I'm sorry, right, for doing this. I'm just gonna say it's identified with its own negation or something, right? So suppose L0 is true. And so let's say these are all the things that make it true, or that make it true up above, and these are all things that do not. Then asserting L0 is true strikes all of this out. but because L0 is true, then L0 is not true, and this strikes out everything else in logical space. So we have maximal informativeness in a sort of contradictory fashion. And that seems sort of right to me because I'm kind of sympathetic to statements being maximally informative in certain cases.
Wait, Thomas, can you say a bit about how the reasoning you did on the last slide corresponds to the earlier reasoning you did? Because it looked like you followed a different procedure than you did earlier.
Okay, well, I did because they're different connectives, but I've got L0.
Yeah.
L0 strikes off all of this stuff from logical space.
Yeah.
But I've assumed L0 is true. So what remains is L0 space, right? This is all the spaces in which it's true. Like all the valuations that verify L0 if there are any.
Yeah.
But in these, because they're identified, must also be the space in which L0 is false.
So, but I mean, we've seen in your earlier examples that you're not holding yourself, once something's crossed out, you're not holding yourself to keeping it crossed out.
Mm.
No, but.
So why are you?
Oh, yes, okay. So then what would happen is that you oscillate, something like this.
That's totally what I was expecting you to do.
Yeah.
Yeah.
In
I told you it was sketchy, right? I did not
evaluation.
promise you a theory, but yeah, no, that is very. That's very. There's a sense, right, in which, yeah, no, I can get with that. Yeah.
Right, so your earlier ones reach limits and this one doesn't, but.
Yeah, no, this doesn't converge.
Yeah.
Something like this. That's interesting, and I'm going to totally keep that in mind.
And you should look at Yablow's early theory of truth to that too.
Okay.
Flipping back and forth, erasing and doing that.
All right. All right. I don't have a whole lot.
How much time do you need?
Can I have like 2 minutes?
Let's give you 5.
No way.
Yeah. I'm a good person like that.
Thank you. You're on my Christmas list. All right. Well, let's say all right. So maybe this is wrong. Maybe it doesn't converge. Or just maybe it's not infinite. Maybe it doesn't converge. I mean, yeah, that's really worthwhile in just thinking about generally recursive procedures in general, because not all recursive procedures converge, right? So yeah, no, that's something that I totally failed to think of. So let's say, boom, not infinite. What is it? Oh. Do you all know that Americanism? Or anybody who has American children? I don't know. I don't know. Yeah. Okay, so let's just take a look at all right, I'm gonna skip over you can clearly sort of come up with an account if you're like an FDE theorist, where you would assume that everything has an extension and an anti-extension, and probably sort of give those same prior probabilities as Barlow and Carnap, because, right, I mean, essentially, right, the anti-extension of a predicate and its extension sort of represent two distinct predicates in some sense. I'm gonna skip over that. It seems that we could, if we were sort of FDE theorists, we could sort of take that sort of approach, right? Or, well, look, what we do, right? Just do this fast, right? This is my L0 axis, and this is my not L0 axis. These are the things that are in fact L0s and not. These are the things that are satisfy the negation of L0, and these are things that do not, right? So L0 knocks out all of these. This is identified with not L0, and this knocks out all of these. So it knocks out 3/4. So you can sort of extend this sort of Barlow-Carnap-y sort of approach to cases in which they're non-classical as well, I think, with some satisfaction. So this seems to be another way of doing it. Also, then, it strikes me that what I found sort of interesting in terms of recursive thing, because that just sort of stops. It's recursive in a sense, but it just stopped after one iteration, is trying to look at this as in a sort of Tarskian mode, right? So let's suppose that L1 is, like zeroth level liar, or this is true, and then I+1, we use the I+1 truth predicate and so forth. Well, then we're going to get a sort of similar thing, right? L0 knocks out everything out here. Dang it. These are things that are not L0, these are things that are L1, boom. This knocks out all those things over there. The next iteration, right, is not L1, right? So we're thinking of this as having like the truth predicate and the target scheme hierarchy of the next level up, right? This is L1. These are the things that falsify, these things that not, these knocks out that, right? This is then identical to L2, and this is L2. These are the things that verify, these things are not. So again, if we treat it in a sort of Tarskian fashion, iteratively, right, we would get, again, the same sort of convergence to 1, which seems likewise kind of right. I have 45 seconds left.
Yeah.
All right, let me say what this has historically felt kind of right to me, at least if we're looking at a sort of Tarskian fashion. What we're doing is we're sort of alternating in sort of the realms that we preclude. But it also strikes me that there might be a problem with this if we think of something, all right, so this is my embarrassing claim, that if we think of not this, but Li is equal to L1, which would be something like a truth teller, right? So L0, right, asserts L0 is true. What does this do? That it rules out all the spaces in which L0 is false. This is identical to L1, right? Because it's a truth teller, it's true, it says I'm true, it goes up, right, every notch. Right, let's think. Well, then L1, right, this rules out, these are things of which L1 is not true. Oh, that rules out those two. And, well, then here's L2. This is L2. These are the things that are not L2s. Boom. And you get the same thing with a truth teller. I just realized that this morning. Because what would be ideal is if a lot of these sort of analyses of the liar produce something that's maximally informative, but then something as vapid as the truth teller should be minimally informative. So I'm a little embarrassed, but I have to be honest and report that, yeah, there's something a little fishy there, because I want the truth teller to slowly open up logical space in a sense. Or maybe just converge at 1/2 or something like this. But the fact that this sort of representation of the truth teller in this form has the same behavior as the liar, I think is sort of, it signs that there's really something left to do on this, and that there's a lot more thought involved. Okay, so at that point, you gave me 5 and I stole 2 more. I'm sorry. But yeah, that is really what I had to say. As I said, it's still very sketchy, so I appreciate the feedback you've given me and any more feedback that you have. And that's that. Yeah, thank you.
Okay, so
Here comes the pain.
C, then D, then Alejandro, then Ramírez.
Just on your last point, it wasn't obvious to me why the truth teller wound up being the same. I believe. Let me just, because I believe you. But instead of thinking that that's something bad, I would have thought that would be a count in favor of your analysis, because I mean, people feel different things about the truth teller and the liar, but they often look like the same sort of phenomenon, and it's like, I guess some people think it's a favor, it's a virtue of a sort of standard consistent gap theory where both the liar and the truth teller get treated the same. Whereas a glut theorist needs to do a little work to sort of justify treating the truth teller the same. So I actually think if you have an analysis where they wind up having the same behavior, that's actually very good.
If you'd noticed, so my setup for this was to give a sort of conjunctive and a disjunctive thing in anticipation of the fact that it would operate in that way. Like the conjunctive way, so look, the Tarskian sort of evaluation of the liar is going to eliminate all these things. Like either the disjunction one, so you can see something that frees up everything, totally anticipating that but yeah, I'm not really strongly convinced that that's how the truth teller should operate. So maybe you're absolutely right. My just sort of natural standpoint just be thinking that, the liar would be totally maximally informative, and the truth teller is empty and vapid and just sort of, yeah, so maybe it's not a problem, I don't know.
It was just a comment to find that you seem to be convinced that there was a problem there, and I actually just the opposite. And the only other small comment is you should probably look at Yadlo's theory of truth, which is built on this flip-floppy sort of intuition, but also, of course, the whole revision theory program would be worthwhile.
Yeah,
that's all.
I hadn't thought about it in this context, but yeah, no, I certainly that is really an important step. So yeah, thank you very much.
Okay, so Dave?
Yeah. Okay, so no, I'm very confused by the diagram procedure, and and it almost feels to me like you've adopted two completely different diagram procedures, one for liar sentences and one for everything else. And I'm trying to figure out, I'm trying to figure out how to understand more. So here's maybe one confusion that I have, and let's forget the liar stuff, and let's just think about the conjunctive case set, right? I would have thought that if P0 really is P0 and P1, then in some sense what you're drawing is not logical space, right? Because P0 and P1 surely entails P1, because conjunctions entail a complex. So if P0 is P0 and P1, then P0 entails P1. And so this idea, so you're representing it as though a quarter of the world satisfy P0 or a quarter of the points or whatever the things are in logical space. Yeah. As though a quarter of them satisfy P0 but not P1, and then you're ruling those out at stage 2. But it would look to me like if this is really equality, the thing you're writing is equality, then there's just nothing there. There's nothing there to rule out. There never was. Right, so there's almost like a representation of a process of discovering things about logical space rather than ruling anything out within it. Or something like that. But I'm not.
Yeah, no, I have to concede that point. My initial reaction would be, well, then let's just walk it back to a propositional language, but that doesn't do any good.
But it's like I just framed it entirely in a propositional.
Yeah. That is.
I think I can represent the process that you're taking up early on, right? Which is just chart all the things up as though they were orthogonal, and then at each stage we have this choice: so we can write down where we are, or we can unfold one step.
Yeah.
Right, and that seemed to be what you were doing with the P0 P1, right? So each stage you write down where you are, and you unfold one step and write down more, and you unfold one step and write down more, right? But it's important that you're replacing each sort of writing down with the earlier one, right? You're not intersecting, you're not unioning, you're replacing. That's how you can cover up more and more in the conjunctive case and cover up less and less.
All right, so there's two issues right here.
Yeah.
There's one that sort of that I take the first claim to be, in a sense, that the priors are completely screwed up here, because if P1 is P1 and P2, then you can't have equal priors there in a sense, right? They should not be treated. One's a special case of the other.
Then there are no points, right? There are no points with P1 without P2.
So I'm thinking about it in terms of, the latter point though, the fact,
I guess it isn't really equality, right? But there's some other unrolling.
Yeah, and maybe this whole idea that maybe really putting in some element of coding or naming, maybe that's essential as well. I don't know exactly what to think.
I don't think there's anything about coding or naming that you need. You just need something step by step.
let's mention the move from I'm not sure if this is going to answer you or if this is orthogonal, but let's think about the case in which P0 is P0 or P1.
P0 or P1.
Yeah, let's say or in this case. So what I was saying was there are P0s, P1s. So let's just suppress the sort of prior, if there are even points situation for right now. What I'm saying is that P0, this rules this out. But then this is also equal to P0 or P1, and this is the P1 axis. And so what this does is recovers that.
Yes.
And you're saying
step 1 with step 2.
You've thereby lost your commitment, in a sense, to P0. If you were committed to P0, you would not have admitted that. You would not have erased that.
Right, because where you just let in a whole bunch of non-P0 points if they're around over there.
All right, my first intuition, my sort of, how would initially want to reply to that? Something articulated. I believe what I'm going to say is false, but in order to sort of, I just need to grapple with it. So what I would initially say is that, look, just because what I've said by saying P0, I've said like I am residing here in logical space, right? I'm in this side when I do the first analysis. And that just because I know I'm living here doesn't mean that I'm saying these aren't possibilities. Yeah, that doesn't satisfy me. It's what is available is sort of a matter of what I think is actual in a sense. I need to reflect on that. I concede that.
So you might think, right, to assert something is to assert everything it's equivalent to. But then you won't have any opening up possibilities, right? Then you'll have to keep any ruling out you do. Right, because the everything is sort of biased towards the ruling out. Right, so that wouldn't get you what you want, but
what I want is the truth, right? I'm like Tom Cruise, right? I don't feel, to the extent that I'm not offering a theory, I'm not gonna feel hurt if what I said is false, because I just want to figure out how do we treat this.
So if you say to assert something is to assert everything that's equal to it, then everything you initially said about all the wire stuff, not the oscillation, was totally ruled out, and then the things that followed on that would all in fact follow.
Yeah.
As well as everything you said about the conjunctive case, right? The only thing that wouldn't fit with that is what you said about the disjunctive case.
That's true. There needs to be, because recursive procedures don't just, oh no, maybe that's the case. Maybe if I think about like a for loop or something, I guess when you try and bridge that gap between things like recursive procedures and propositional calculus, it's always messy, right? Because you don't have that sort of functionality that's so inherent in that case. So I don't even know if there is a good translation between the two. Maybe recursive procedures always just shut more and more things out by definition. If they don't sort of replace variables or something. Maybe that's what it does. Maybe they shouldn't ever free up things. If that's the case, then I guess that would make sense why the truth ever have the same analysis. I don't know. I want there to be some sort of disjunctive freeing up. But yeah, no, it's certainly, I can't approach it in as hasty a fashion as I've done. So I don't really know what more I can sort of say to respond to that other than thank you. That's food for thought, and it was very valuable. Let's
talk more about that too.
Okay. All right. Thank you.
Lavinia had a follow-up on this.
Yeah, well, I thought that maybe the problem here is that you're drawing two axes, whereas
there's just one, because P0 and P1 are the same thing, so basically before drawing axis, you should check that everything is independent.
Yeah, that seems like sort of relevant to today's first.
Yeah, exactly.
It seems that these problems are coming up with disjunctive case more, right?
No, I think it also, I mean, you cannot erase things, because information is cumulative, right? So, I think it's also for the liar.
Unless the lines actually represent epistemic states or something, then
Right.
that's not what you've been doing, but that would motivate what you're doing.
Yep. But then you shouldn't accumulate in any of the liar cases either, right? And this would get you a difference between the liar and the truth teller. If you replace it every stage, right? The truth teller will stabilize immediately. The liar will continue to oscillate.
You know?
Okay. Yeah, thank you very much for the comment. Yeah, these are very helpful. Yeah, thanks. All right.
Have you considered this approach that measures the informational content through complexity? Because according to that approach, even tautologies are informative, because since compositional logic is NP-hard, like you measure that according to the cognitive effort or like the computational resources you have, even tautologies are informative. And personally, I don't like the idea that tautologies are not informative at all.
So there is, right, so this whole scandal of deduction thing. The Hindika coined this, wrote a couple of papers on it. I don't really like the Hindika stuff, but, and I don't really, actually there's a paper by D'Agostino and Fruity on this. And I'm not totally satisfied with the details, but I like that idea that what the information that's being imparted through sort of a priori stuff is bounded by complexity, right? That's what sort of gives it its informational oomph, is that I required resources in order to figure out from, A implies B and A, I needed to use resources in order to infer that. And that seems very tightly bound with complexity. So I like the general idea of that approach. I don't necessarily really like the details or how it's been implemented, but I think there's a lot of good stuff there. Yeah. Thanks.
Thanks.
Yeah, so my point was basically Dave, that I thought there was like an ambiguity in the readings of the things. But I'm gonna then mention something really minor. He had a self-referential sentence in the beginning, which said this sentence has 6 words or so. And you said that you thought that was informative because it's certainly contingent. You said it was contingent, and therefore, I mean, you had said by then this conditional informativity.
Yeah, no, maybe that's absolutely right. Maybe it's not fun.
I don't think it's contingent at all, right? Because of the identity conditions of sentences.
It's that you're probably entirely right. I think of I was coming from that perspective that I think of that property as being like a contingent property, the things that hold of things in the world. But yeah, no, that isn't informative. But you see, again, that sort of so I was wrong, but you're right.
No,
No, you're totally right. I agree with you. I don't know, I'm not, by saying that, I wasn't indicating I think you're attacking me or something, you're totally
No, I know, but I don't think that I'm right. I think the problem here is, so I don't think either of us is right.
Okay.
The problem I think here is with the contingency requirement, because as now you see, you have a sentence that is a theorem of a theory of syntax, which is not logical, right, anymore, but still an informative, and that's fine. It's like any number, any theorem of arithmetic is an informative, and then like a lot of things that people would usually regard as informative or something not informative.
Yeah, So you're right in the sense that modulo that theory, it's uninformative, I think. Modulo is saying it's uninformative. You're right also that it does appear informative, and it shouldn't be treated as uninformative.
Because it's not a tautology, right? It does cut like, if you're working, for instance, with model theory,
yeah,
it does get rid of a lot of models, right?
Well, that's why I think the information stuff is so interesting, is because it's tied up with both alleviate concerns and epistemic concerns, right? And then you have like the same sort of, well, look, I mean, it's a necessary truth that water is equal to H2O. So, like, that's not something I can learn or something, right? I can't, like, you have those sort of epistemic concerns with metaphysics, right? And it's sort of, I think, along those lines. Like, this is the metaphysics of the sentence, things that's necessarily true, right? The metaphysics of strings of symbols and so forth. But there's still a sense in which it's communicating something to you, in the same way that I'm communicating something to you when I teach you that water is H2O, right? So yeah, that's why it's interesting. I'm not fully, yeah.
What if we replace the notion of necessity with just logical truth in the more like in the more formal sense, right? So where the form plays a role. So basically, work just with models of, I mean, like water is H2O is not going to be a logical truth under like this approach, although necessary. So maybe instead of talking about necessarily contingent propositions, it would be better to have just logical truths in the traditional sense.
Yeah, so I have this slide that I skipped past about what are the possibilities. And right, there are a lot of different ways to take it, because I don't want to say they're necessarily probabilities. I kind of want to say they're possibilities, but still, I want to retain enough room for things like truths of arithmetic being true, despite holding every possible world. So yeah, there's a lot of subtle stuff right there that are just lying under the surface that you immediately start digging at here, and all sorts of things arise, which is why I think the information stuff is interesting, because these things pop up. But yeah, no, I am absolutely sympathetic to that concern. Okay.
Any other questions? Well, then let's thank Thomas again.
All right. Thank you.